For our last section, we're going to talk about what happens when triangles are similar rather than congruent. So when we say similar, this is different from congruent. Congruent means every measure of everything is the same. All the measures of the sides are the same. All the measures of the angles are the same. What that means for the triangles is they are the exact same shape and the exact same size. For similar, they still have to be the exact same size. The exact same shape, but not the exact same size. They're going to be in perfect proportion. All the sides will be proportion. Well, all the angles will be the same. And that's true not just for triangles, but for any figure as you see here. All right, so for similarity, we're going to use this symbol. This means similar, whereas the equal sign with the squiggle over it means congruent. Okay, so just make a note of that. Oops, didn't mean to write over that. Let me just get that. Okay. All right, so looking at number 1 here. Triangle UTV is similar to triangle LKM. So we know that the angles have to be congruent. So the order of everything tells me that angle U is congruent to angle L, angle T is congruent to angle K, and angle V is congruent to angle M. All right, and I know that the sides have to be in proportion. So what that means is I can set up ratios. So the longest side here between U and V is 18. And that is proportional to the side between L and M, which is 24. So I'm going to set up a ratio, 18 to 24. Okay? Now, if I set up ratios between other corresponding sides, they have to come out to be the same fraction. So this has to be equal to what I get if I take the distance from U to T, which is X, and divide it by the corresponding side in the other triangle, which is from L to K, which is 16. So I have two fractions equal to each other. The best way to solve equations of this sort is what we call cross-multiplying, where we multiply top to bottom like that, top to bottom like that, set them equal to each other. So 24x equals 18 times 16. 18 times 16 is 288, so 24x equals 288, and then I just divide, and I get x equals 12. I always kind of put it on there and make sure it makes sense. Okay, so 18 is half again as big as 12. 24 is half again as big as 16, so it all sort of fits together. All right, looking at number 2. In the first triangle, we see that they're isosceles. We see that these two sides are the same. So, actually, if we know that the two triangles are congruent, we don't even have to set up ratios like we did on the first one. We can, but we're going to wind up being able to say that this side has to equal this side. Because if one of them is isosceles, the other one has to be too. Let's just show how that works. U is congruent to M. V is congruent to K, being very careful here, which means W is congruent to L. Okay, so 3x minus 1 is the side between the single angle and the triple angle. So that's congruent to the side UW, which is 4. Or not congruent, I'm sorry, proportional to 4. The side MK is 8, and it's proportional to the side UV, which is 4. Now we see that we have two fractions just like before, and we could cross multiply just like before. But we also see that there's a 4 in the denominator of both sides. So I can simply multiply both sides of the equation by 4. And that's going to cancel out with the denominator. So I have 3x minus 1 equals 8, which I said I could have done from the very beginning. I'm going to move the 1 over and say 3x equals 9, and then I'm going to divide by 3, and I get x equals 3. Now, that doesn't tell me what the missing side is. Now, the directions did just say to solve for x, but it's a good idea to get a habit of just going ahead and figuring out what the missing parts are. So, if x is 3, 3 times 3 minus 1 gives me 9 minus 1, which is equal to 8. All right, one last example here. This time, the two similar triangles are actually stacked on top of each other. But everything still matches up. Angle C is congruent to itself. Angle T is congruent to angle E. Angle S is congruent to angle D, right? According to the congruent statement. So that means the sides have to be proportional. So the long side over here on the right, 40, divided by the shorter triangle there on the right, which is 8. That ratio has to be equal to the long bottom side, 18 plus 3x over 12. Okay, I'm going to cross multiply. So 8 times 18 plus 3x is equal to 40 times 12. Well, here, this is just 480. Over here, I'm going to have to distribute. 8 times 18 gives me 144, and 8 times 3x gives me 24x. I'm going to get rid of the 144 by subtraction. And I get 24x equals 336. Lastly, I just have to divide by 24, and I get x equals 14. So this missing side then, here, is 18 plus 3 times 14, which gives me 60. Just kind of reality check things. 40 is 5 times 8. So according to the right-hand side, the big triangle is 5 times as big as the little triangle. I realize it's not drawn to scale. 60 is 5 times 12. So that fits. Everything is proportional with a scale factor of 5. Similar triangles are a result of dilation. We did transformations in the last unit. Congruent triangles result from any of the other transformations, but similar triangles result from dilation.